Welcome to Module 16. This module focuses on the spying of web application traffic. As you've discovered in Module 14, which focused on the XSS vulnerabilities, exploiting these flaws could have serious consequences for users of vulnerable services. User data, such as session IDs, could be stolen and malware could be installed on a victim's computer. As you know, it's feasible to execute any JavaScript browser-side. There are also other means of exploiting these holes. Using several simple tricks, an attack is able to write a script which will monitor all operations executed by a web application user, and which will be active as long as a given browser window is kept open. You can see here a simple code for the sniffer. The load sniffer function launches the sniffer. First, it creates a secondary XML HTTP request object used for AJAX requests. Then loads all links and forms in a website. Let's see the sources for these functions. The collect links function is used to load all link tags from the current document and replace target addresses with JavaScript function calls, where the link's URL is the parameter. In the collect forms function, a form's target address is replaced by a function call which assumes the number of the form of the parameter. Let's now take a look at the load URL function. At first, the send-to-attacker function is called, which we'll discuss in a minute. Its source is set to the URL which a user attempted to click, and parameters are set to have the frame fill an entire page. The frame is added to the website's DOM tree, and display delay is set to 400 milliseconds. After this time, the site should preload. The script tag is also added, which loads the code of our sniffer. Next, the load sniffer function is called to parse the page. Let's now focus on the send-to-attacker function. We can see that a referral address is being prepared, which will pass captured data, such as website URL or form content, to our sniffer through the GET parameter. XML HTTP request object references to pages from other domains are disabled in virtually all browsers for security reasons. To circumvent this, a script tag is created and the generated sniffer link is submitted as the URL. Next, the tag is added to the DOM tree, so an attempt will be made to load the script, which will execute the GET request and send data to the sniffer. Let's see the sniffer code now. As you can see, all past parameters are logged in the sniffer log file. As for now, the sniffer log is empty. Let's take a look at the source code for our website. In this case, the sniffer's been injected directly into the code, but it's equally probable that an attacker could have inserted it into the service, using the cross-site scripting vulnerabilities. You can see here several links to subpages and a form. The sniffer code is not executed on the subpages. Let's see now how the site works in practice. You can see here the main page. Links have been replaced with load URL function calls. Let's click on the first link. This page has also been parsed by the sniffer. Let's open the second and third links. Now go back to the main page, put a string in the form and try to send it. Let's see the contents of the sniffer log file. As you can see, all calls have been captured, including the values sent through the form. A potential attacker may be able to monitor all operations performed by a victim in this way. Let's try to think of ways in which we could protect ourselves against these attacks. As web developers, we should above all take care of the XSS vulnerabilities. We should also make use of a frame killer. If our page is open in an iframe, the code will redirect an entire browser window to the frame's URL, causing the page to reload outside the frame. In this way, the page outside the frame with all embedded scripts will be skipped. As users, we should be on alert if the address in the bar does not change, even if we have browsed through several pages. What's more, if by hovering over a link we discover that the displayed URL executes JavaScript, we should remain extra cautious. Some newer browsers disable JavaScript access to frames with URLs and domains different than the URL of the window. That's all in this module. Thanks for your attention and see you in the next module where we will focus on session hijacking.